Welcome to Educare. Today in this video, the operating principle of three-phase induction motor will be explained. This is the stator of three-phase induction motor and this is the rotor of the three-phase induction motor. The total inner periphery of the stator is arranged with open type of slots. For your better understanding, I have shown only 3 slots, 1, 2, 3. Similarly, the total outer periphery of the rotor is arranged with semi-closed slots. Again, for your better understanding, I have shown only for 3 slots for 3 phases. Now, question is why stator slot is open type of slot and the rotor slot is semi-closed slot. The semi-closed slots is mechanically strong. Since the rotor is rotating, therefore the winding of the slots should not be come out. Therefore, it is arranged with semi-closed slots. But the semi-closed slots design is very difficult and maintenance work is high. The stator winding is stationary. Easy of maintenance work. It is arranged with open type of slots. Let these slots corresponding to R phase and these slots corresponding to Y phase and these slots corresponding to B phase. That means in this slot R phase winding will be accommodated here and these slots Y phase winding will be accommodated here and in this slot B phase winding will be accommodated here. That means this is the R phase, Y phase and B phase. These three phase stator winding must be displaced by 120-degree electrical with respect to space. That means this angle should be 120-degree. This angle must be 120-degree and this angle must be 120-degree. This stator winding, three-phase stator winding can be connected in star mode or delta mode depending on which type of starting method we are using. That means if this is the R phase winding, this is the Y phase winding, this is the B phase winding. This is R, this is your Y and this is your B. And this angle should be 120-degree. This angle should be 120-degree. This angle should be 120-degree. This is star connection. Or for delta connection, this should be R phase, this should be Y phase, and this should be B phase. That is R phase winding, that is your Y phase winding, this is your B phase winding. Now a three-phase supply is applied to the three-phase winding of the stators. This is your three-phase supply of frequency f Hertz. Therefore, a three-phase current will be drawn from the supply for the three-phase R, Y and B. This is the current I of R. This is the current I of Y. This is the current I of B. This three-phase current must be displaced by 120-degree electrical with respect to time. That means if I draw the phasor of this three-phase current, that must be like this. This is the I of R. This should be the I of Y. This should be the I of B, and this angle should be 120-degree, this angle should be 120-degree, and this angle should be 120-degree. If these two condition, this is the condition number 1, this is the condition number 2. Condition number 1, that means the three-phase stator winding must be displaced by 120-degree electrical with respect to space and may be connected in star or delta. Condition number 2, the current which is drawn from the supply for the three phase must be displaced by 120-degree electrical with respect to time. If these two conditions is satisfied, then a rotating magnetic field will be produced into the three-phase induction motor. How the three-phase rotating magnetic field is produced in the coming video I will explain. For the time being, you just consider a rotating magnetic field is produced, and the speed of the rotating magnetic field is called the synchronous speed n of s, and it is given by 120 f by p, where f is the supply frequency, p is the number of pole of the induction motor. Similarly, a three-phase distributed winding is arranged into the rotor slots. Let this is the A phase winding, this is the B phase winding, and this is the C phase winding. And these three-phase winding, rotor winding, must be connected into the star mode. Let this is the A phase winding, this is the B phase winding, and this is the C phase winding. One point must be clear: the stator winding may be connected in star or delta, but the rotor winding must be connected in only star. Why this things is done? In class number 37, I have explained that the advantages of star mode is that number of winding per phase is less. Again, for star winding, insulation material required is less. Therefore, the size of the rotor will be less, and therefore the efficiency of the motor will be increased. Therefore, the stator flux rotates in the air gap at a speed of synchronous speed ns, and at the standstill the speed of the rotor n of r is 0. The speed of the stator field is ns at a standstill. That means rotor is not rotating. The rotor speed n of r equal to 0. Therefore, the relative speed between the stator field and the rotor is ns minus of nr, that is ns minus of 0, that is equal to n of s. That means the rotor conductor feel there is a rate of change of flux. According to transformer action, an EMF will be induced into the rotor winding. Let the EMF induced into the A phase winding is E of A, B phase rotor winding is E of B, and C phase rotor winding is E of C. How the EMF will be induced into the rotor winding due to transformer action has been clearly described into the transformer operating principle. If you have any doubt, please go through that video. Link will be given to the description box. Now, if the rotor winding is short circuited like this, depending on how the rotor winding is short circuited, the three-phase induction motor is categorized into two types. It will be explained into the construction part of this induction motor. For the time being, it's just you remember, for the slip ring induction motor, the rotor winding is short circuited through slip ring, and for the squirrel cage induction motor, the rotor winding is short circuited by end ring. When the rotor winding is short circuited, then a three-phase current will be circulate through the three-phase rotor winding. Now, the direction of this induced current is according to Lenz's law. so that it will oppose very cause of its production. What is the cause? Cause is the rotating magnetic field. And what is the production? Production is the induced current. Therefore, to oppose the relative speed of the stator field, rotor starts rotating n of r in the same direction of the rotating magnetic field. But always the rotor speed n of r must be less than synchronous speed n of s. Now the speed of the rotor must be less than of synchronous speed. If by chance the rotor speed becomes the synchronous speed, that means ns and nr becomes equal, then there should not be no relative speed between the stator field and rotor conductor. No induced EMF, no induced current, no torque, no rotation. Therefore, that ns should be greater than n of r, and ns minus of n of r is called slip speed. And slip is given by ns minus of nr by of n of s, and percentage slip is given by ns minus nr divided by ns into 100%. You should remember this formula again. This is the operating principle of this three-phase induction motor, how the rotor rotates. Thank you once again.